Ondrives in Chesterfield. Now these guys are absolute masters of gear manufacturing and gearbox manufacturing. Gary, this is your pride and joy, shall we say? Can you tell people what it is, what it do, and all about it, please?
Well, basically it's a gear teeth grinder. It can do helicals, big gears, small gears, spare gears, splines. It's really, really good machine.
Any sort of gear, really?
Basically, obviously not bevels, but helicals, splines, we can use as all sorts of pitches. It goes up to 855 diameter, as small as we can get on. Smallest pitch we do is probably about 0.4. It's very, very accurate. It's got a number of features for tooth profiling, modifications, root, parabora root modifications, as well as flanks, etc., etc. So yes, it just goes on and on and on.
Yeah, now, big fan of it. Now you said very accurate. When you're talking gear cutting, you're talking DIN. So what will this go to? And for the sort of, let's say day-to-day engineers, that's right, in sort of micron terms, what would that be as well?
Obviously, depending on pitch and size of gearing, I'd expect to get on a regular basis probably at least a grade 4 DIN 4 gear, but that's all dependent on size and gear. But as accuracy goes, it's very, very good.
And the uneducated out there, that's probably 2 or 3 microns?
Yes, maybe a little bit more, as again on pitch size, 2, 3, 4 microns. The machine itself is really, really good as it's got technology in it which makes programming it a lot easier and a lot more understandable, which makes everybody's job and the gear a lot easier to manufacture.
So you can actually program it here offline?
Yes.
Okay. Now just going back then, materials, any sort of material?
Any metals, basically, yeah. I found nothing that I can't grind yet, which is lucky. Obviously everything's down to precision finish, tooth finish. With grinding, it's all about the finish and the quality.
Now also, we mentioned the materials there, but I'm thinking, why don't you use this on a normal machine tool, maybe a lathe or even a mill?
You've got the options of modifying teeth. You have to buy a cutter at a great expense, and basically what you then have to do is you're stuck with the profile of that cutter. With a gear grinder, you can shape your teeth to whatever you want. Hence, modifications become easier, tooth shape become easier, and so it's just very, very easy to do. It's with buying a cutter and tips and things, they always breaking and breaking. With this, they basically just regrind them. You get a blank disc, put your form on the disc, and from there you shape your tooth.
And you can change that form to whatever you want in terms
of any shape you want.
Now, just looking in the background, you've got the software there, and it's got a few shapes on it. I'm thinking, is that where you're roughing and then you're finishing?
That's correct. That'll show you the number of steps it is to be grinding. So you'll start with obviously a deeper cut at quite a slow speed because you're actually going in deep, and then you'll go to a finishing, which cleans the flanks up and makes it correct.
And when you say going in deep, though, I mean that's only it's
0.2 at the most. So that is deep for obviously it's not creep fine greepy, but it's it's deep enough.
Gary, that's absolutely brilliant. That's a Gleason machine. You don't see many of these in the UK at all. So absolutely fantastic, perfect for any sort of gear cutting, really.
Yes, that's correct. Anything.
Thank you very much.